Have you ever wondered how our sun, the fiery ball of energy in the sky, came into existence? It's a fascinating journey, one that spans billions of years and influences every aspect of life on Earth. Our sun, this celestial powerhouse, has a life cycle just like us, and its role as our primary energy source is vital. From providing light and heat to powering photosynthesis, the sun's contribution is immense. So, let's dive into the captivating cosmos to unravel the mysteries of our sun's life. The birth of our sun is a tale that dates back around 4.6 billion years ago. This story begins not with a fiery blaze but with a nebula, a vast cosmic cloud of gas and dust. As these particles swirled in the darkness of space, something incredible began to happen. The force of gravity started to pull these particles together, drawing them closer and closer. As this process continued, the center of this cloud began to heat up, forming a protostar. This protostar was the sun's first step towards becoming the star we know today. As the protostar continued to grow and heat up, it eventually reached the point where nuclear fusion could occur. This ignited the protostar, turning it into a fully fledged star, shining brightly in the darkness of space. And thus, from the humble beginnings of a cosmic cloud, our sun was born. Once born, our sun entered a phase known as the main sequence. This isn't just a fancy term astronomers use to impress each other at stargazing parties. The main sequence is a critical stage in a star's life cycle, and it's where our sun is currently holding court. So, what exactly happens during the main sequence? In essence, our sun is hosting the universe's most epic barbecue. At its core, the sun is burning hydrogen, the most abundant element in the universe, and transforming it into helium. This process, called nuclear fusion, releases an incredible amount of energy. It's like the sun is constantly setting off 1 billion atomic bombs every second, but don't worry. It's all happening safely 93 million miles away. This energy radiates out from the sun's core, making its way to the surface, and then it embarks on an 8-minute journey across the vastness of space to reach us here on Earth. This energy is the warmth you feel on your skin on a sunny day. It's the light that makes our world bright and beautiful. It's the power that drives weather patterns and fuels life on our planet. Now you might be wondering, how long can this party last? Well, the main sequence phase is kind of like the star's middle age, and it lasts for about 10 billion years. Yes, that's billion with a B. To put that in perspective, if the entire history of the universe was condensed into a single year, the main sequence would last from July to December. So where does our sun fall in this timeline? Our diligent worker of a sun has been burning brightly in the main sequence for about 4.6 billion years. It's been providing us with the energy we need to live, grow, and thrive. And the good news is, it's only halfway through its main sequence. In human terms, our sun is middle-aged, but don't expect it to buy a sports car anytime soon. Instead, it will continue to burn hydrogen, provide us with energy, and light up our skies for billions of years to come. Our sun, like a diligent worker, has been in this phase, providing us energy for about 4.6 billion years. But what happens when the sun exhausts its hydrogen supply, you might ask? Well, it's a fascinating and, dare I say, fiery process. The sun, like any other star, won't simply flicker out when its hydrogen fuel runs dry. Instead, it will undergo a series of dramatic transformations, a celestial metamorphosis, if you will. The first stage of this transformation sees our sun become a red giant. Now you must be wondering, what turns our warm yellow sun into a red giant? The answer lies in helium, the next element in line after hydrogen. As the sun uses up its hydrogen, it leaves behind helium. Over billions of years, the core of the sun becomes so dense with helium that it begins to collapse under its own gravity. This collapse raises the temperature and pressure in the core, eventually reaching a point where helium can start to burn, or fuse, into even heavier elements like carbon and oxygen. And this new phase of helium burning marks the beginning of the sun's twilight years, its red giant phase. The sun, now burning helium, begins to swell, expanding to a size so enormous that it could potentially swallow up the Earth. Imagine that, our sun, once a comforting, life-giving presence, turning into a colossal, Earth-engulfing entity. But fear not, this red giant phase won't last forever. After about 1 billion years, our sun will have converted most of its helium into carbon and oxygen. The core, now heavier, will shrink and heat up, causing the outer layers of the sun to expand and cool down. Eventually, the sun will shed these outer layers, leaving behind a hot, dense core. This shedding process, while sounding terrifying, is actually quite beautiful, creating a cosmic display of light and color known as a planetary nebula. And so, as we journey through the cosmos, we see that even our mighty sun has a life cycle, a beginning and an end. But remember, every ending is also a new beginning. As the sun's twilight approaches, it prepares to bid its final goodbye. In the end, what remains of our sun is a white dwarf. As the sun exhausts its nuclear fuel, it sheds its outer layers, leaving behind a dense, hot core. This is the white dwarf, a final state of our sun no larger than Earth, yet carrying the mass of the sun. This white dwarf will then embark on a journey of cooling down, a process that will take billions of years. Imagine a hot coal in a campfire. After the flames die down, the coal continues to glow, its warmth slowly fading into the night. That's a similar fate to our sun's white dwarf. Over unimaginable spans of time, this glowing ember of a star will lose its residual heat. When it finally stops emitting light and heat, it becomes what we call a black dwarf. This silent, dark relic is the sun's ultimate legacy. And so, the sun, having lived a fiery life, will retire as a silent, dark relic of its past. Throughout its life, the sun plays a critical role as an energy source. Its radiant light and warmth are essential in making Earth habitable. The sun's rays drive photosynthesis, the process through which plants produce food and oxygen. This fundamental process underpins all life on our planet. Moreover, the sun is the powerhouse of renewable solar energy, an increasingly vital resource in our sustainable future. Our sun, the heart of our solar system, silently fuels life with its ceaseless energy.